Hi, I'm Mr. Huber, and in this exercise I would like to work out exercise 10C. Well, in exercise 10C we're given P is equal to 28 and Q is equal to 63. Again, we're going to draw, well, that's 10C. We're going to draw a right-angled triangle. Just a quick hand sketch. This is the right angle. Here, this is the height. This is P28. This is Q63. A, B, C. This is B. This is A. This is C. This is the angle beta. And this is the angle alpha. So now we have to start off the exercise by using Q and P. So we can't directly work out an angle, but we can use the altitude on hypotenuse theorem that states h squared is equal to PQ. That's a good way to start this thing off. So h is in fact the square root of P times Q. P is 28 and Q is 63. So the height is going to be the square root of 28 times 63. That's 42. This is even an exact value. Okay, it's an exact value, 42. So once we've done that, we could work out alpha. Look. In this triangle, it's easy to work out alpha. So we could say tangent alpha is opposite over adjacent. So opposite is h over adjacent is q. So we know quite a few values. We know 2. We have to know 2 in order to work out the third one. Tangent alpha is the height, which is 42. Over 63. So alpha is arc tangent of 42 over 63. You have to use the inverse function, the inverse tangent. So let's type this in. Arc tangent 42 divided by 63. And we're going to get 33.69 degrees. Well, from here on, let's store it. Shift store A. We've stored it as A. Why not? We might use it some other time. Okay. Now, beta is now very easy to work out because it's 90 degrees minus alpha. Why is that again? Because alpha plus beta is plus the 90-degree angle is 180 degrees. So that means alpha and beta must be 90 degrees, which means you just subtract alpha from 90 degrees, which is obviously 56.31 degrees. But this is an approximate value. Good. So now we have the two angles. Well, now we could carry on with trigonometry, or we could use the theorems, the Pythagoras theorems, Euclid's theorem to be exact. Because look, C is in fact P plus Q. So C is 28 plus 63. That's 91. That's obvious. If this is Q and this is P, then C is the sum of them. It's 91. Well, now you could use the following. B squared is QC. Because this is Euclid's theorem, and you know Q and C, 63 times 91. B is the square root of 63 times 91. Square root of 63 times 91. Let's try again. It's 21 times the square root of 13, which is approximately equal to 75.72 units of length. And now you could use the other one. A squared is equal to PC. So A is the square root. It's again Euclid's theorem for the other side. P is 28 times 91. So A is the square root of 28 times 91. And we get approximately 50.48 units of length. Obviously, you don't have to do it like this. You don't have to use Pythagoras. You could have done it like this. You could have said, well, if I know alpha, beta, the height, I could work out B, for example. I could say, well, sine in the red triangle, sine of alpha is opposite over hypotenuse, h over b. In this red triangle, well, h over b. As we know h, we could work out b, because sine of 33.69 degrees is 42 over b. You multiply everything by b. You get b times sine of 33.69 degrees. That's 42. Then you divide by sine of 33.69 degrees. So you get b is 42 over sine of 33.69 degrees. In an exam, if you don't use the rounded value, well, it's not perfect, but well, I will still give you all the marks. But I'm going to use the stored value here because I stored the angle alpha. So it's 42 divided by sine of 33.69, which is in my case A. Here we go. And that's 75.72. And you could have done it on the other side as well, or you could use, let's just carry on and work out A. You could do it like this, sine, and now in the large triangle, it's just another method. Sine alpha is opposite over the hypotenuse. Opposite over the hypotenuse. So sine alpha is A over the hypotenuse. We know the hypotenuse. We don't know A, but we do know sine alpha. So sine of 33.69 degrees. We don't know A, but we do know C. That's 91. So A is 91 times the sine of 33.69 degrees. So let's try that. 91 times sine, recall A, because we stored that as value A, and we get A is equal to 50.48. So you see, I've shown you several options now. You can do whatever you like as long as you stick to the rules. I hope it wasn't too difficult. See you on the next one.